Assalamu alaikum and welcome to Cambridge Chemistry channel. Um, be sure to like the video and subscribe it. Really helps the channel to grow. Today I will explain the entropy. The title is entropy. Entropy actually it is the measure of entropy is the measure of disorder of the system. Symbol of entropy is S, and unit of entropy is joule Kelvin inverse 1 mole inverse 1. Entropy, that the more the disorder of the system, greater the entropy. you know States of matter like solid, liquid and gas. Solid in solid particles are closely packed. So this is most ordered system, ordered, and entropy is 0. But in liquid, particles are not closely packed. This is disorder of the system. This is less ordered system. Then solid, and entropy is increased. Entropy is more than 0. So in gas, particles are more disordered particles. This is the gas particles, more disordered. So entropy is maximum. So look at the example. In case of chemical reaction like ammonium nitrate in solid state, it is most ordered, and when dissolved in water become aqueous. Disordered, entropy 0. Over here entropy 0. In this case entropy is not 0. So it means disorder of the system, disorder or entropy is increased when solid changes into aqueous solution. So changing, there is another example, changing of states of matter. Solid changes into liquid and liquid changes into gas. This is melting. This process is melting. This is boiling. Entropy is increased. Entropy is increased from solid to gas. So it means in gas particles, most disordered particles, solid ordered particles, liquid disorder is going to increase, and gas is most disordered system. But when solid gas changes into liquid, gas changes into liquid and liquid changes into solid. This process is condensation, and this process is freezing. So entropy is decreased when gas changes into solid state. Entropy is increased. Entropy is decreased. Entropy is decreased when gas changes into liquid and liquid changes into solid state. Standard entropy is the disordered of the system under standard conditions. Under standard conditions, represented with delta S. Standard conditions are temperature is 298 Kelvin, pressure is 1 atmospheric and concentration if there is a solution, that is 1 mole per dm cube. You know in nature that there are some reactions which are spontaneous. There are certain reactions which are spontaneous reaction, which happen without the influence of any external agent. And there is another reaction which is non-spontaneous. For example, diffusion of gases, evaporation, reaction of group 1 metal, and there are certain reactions which are non-spontaneous, which require energy to happen. For example, thermal decomposition of ionic compound. Electrolytic decomposition of ionic compound. You know that this is entropy is the application of second law of thermodynamics, which explains second law of thermodynamics. Which states that the entropy of an isolated system will tend to increase over time. For example, when gas particles diffuses, they are mixing with each other, and becoming more random or disordered. The disorder of the solute is increased when it dissolves in water. When it dissolves in water. How we predict the entropy, whether it is positive or whether it is negative during the chemical reaction. For example, more the number of atoms, delta S is, that is positive delta S entropy. More the number of moles of gas, positive entropy, and higher the temperature. When we increase temperature, you know that the particles move more randomly and kinetic energy is increased. So when kinetic energy is increased, more disorder of the system and entropy is positive. And decrease the number of atoms, entropy is negative. Decrease the number of moles, negative entropy. For example, N2 nitrogen react with hydrogen to form ammonia, 2NH3. So on the reactant side there are 4 mole of gases, and on the product side there are 2 moles of gas. So on reactant side delta S is positive because there are more number of moles of gases. On the product side, delta S is negative because number of moles are going to decrease. So there is another example, calcium carbonate, thermal decomposition of calcium carbonate, decomposition calcium carbonate to form calcium oxide plus carbon dioxide gas. On the product side, delta S is 0 because it is calcium carbonate is in solid state, entropy is 0. So in solid state entropy is 0, but because there are 1 mole of gas, so on the product side delta S is increased and delta S is positive. Over here negative. So there is another example, methane when react with oxygen to form carbon dioxide plus water. So on the reactant side there are 3 moles of gases and on product side 1 mole of gas. So this is liquid, this is gas, this is gas. So reactant side entropy is positive, increased, and on the product side delta S is because only 1 mole of gas, entropy is negative or decreased. But if the number of moles of gases are same on both sides, for example H2I2 and to form 2HI, hydrogen iodide. On this side 2 moles, 2 mole of gas, and product side 2 mole of gas. So there is no change in entropy, the entropy remain the same, delta S, no change in entropy because the number of moles are same on both sides, no change in entropy. So we can calculate the overall entropy of the system by using delta S is equal to sum of delta S of product minus sum of delta S reactant. Consider this example, nitrogen react with hydrogen to form ammonia. So entropy of nitrogen is 192, entropy of hydrogen is 131 into 3 mole, and entropy of ammonia is 193 So delta S is equal to sum of delta S product minus sum of delta S reactant. So we know that 192 plus 131 into 3 minus product is 193 into 2, 193 into 2 and minus 192 nitrogen plus 3 into 131. So we can calculate this.